Imagine a metal that just won't give up, a material so tough that it doesn't break, so stubborn that it doesn't rust, and so resilient that it barely melts, even in temperatures that would turn other metals into soup. It sounds like something from a science fiction movie, doesn't it? But this isn't fiction, this is science. Scientists have just announced the creation of a brand new metal alloy that does all of these amazing things. This discovery could change everything we know about building strong, long-lasting machines. It's an exciting time to be thinking about the future of materials. Engineers are always looking for better materials to build the world around us. Think about a jet engine. It's a powerhouse of controlled explosions, spinning thousands of times per minute and getting incredibly hot. The blades inside have to be unbelievably strong to handle all that stress and heat. If a blade were to break, it could be a very serious problem. That's why we need materials that are not only strong, but also reliable under extreme conditions. The search for the perfect metal is a constant quest to make our machines safer, more powerful, and more efficient for everyone. The metals we use today, like nickel-based superalloys, are pretty good, but they have their limits. When they get too hot, they start to weaken, and they can be damaged by the oxygen in the air, a process we call oxidation, which is like a high-speed version of rust. This new wonder metal, however, is completely different. It scoffs at temperatures that would make other advanced alloys begin to fail. It stays strong and ductile, meaning it can be shaped without shattering, even at room temperature, which is something most other superheat-resistant metals struggle with. This combination of properties is what makes it a true game-changer. This isn't just about being strong, it's about being strong in the right way. When other special metals get hot, they often become brittle and can crack easily. This new alloy does the opposite. It actually work hardens, which means that when you put it under pressure, it gets even stronger instead of breaking. It creates its own protective shield against rust and corrosion, even in air heated to a scorching 1,100 degrees Celsius. This unique ability to protect itself from the very things that destroy other metals is what makes scientists so incredibly thrilled about what it can do for our future. So, what is this magnificent metal made of? The recipe is surprisingly simple, but the results are extraordinary. The main ingredients are two elements you might have heard of, chromium and molybdenum. Scientists mixed them together and then added a tiny but very important dash of a third element, silicon. Just a small amount, only about 3%. This specific combination creates a material with a special internal structure, known as a body-centered cubic structure. This crystal arrangement is the key to its incredible strength and its ability to be shaped without breaking, a property we call ductility. The real magic happens when this alloy gets hot. At high temperatures, the chromium near the surface reacts with oxygen in the air to form a super thin, super dense protective layer of chromium oxide. Think of it like a perfectly sealed, invisible coat of armor that stops any more oxygen from getting in and causing damage. This is a huge deal because most metals get weaker when they oxidize. This one builds its own fortress wall to keep itself safe, allowing it to operate in blazing hot environments where other materials would simply burn away or fall apart over time. Underneath that first protective layer, another amazing thing occurs. The molybdenum atoms arrange themselves to form a secondary barrier. This zone is special because it blocks other damaging elements like nitrogen from sneaking into the metal and making it brittle. Even more impressively, the tiny amount of silicon in the mix helps stabilize the protective oxide layer and prevents the molybdenum from forming a crumbly, volatile substance that would cause the metal to degrade. It's a brilliant example of chemical teamwork where each element plays a specific role to protect the whole. This self-protecting mechanism is what sets this alloy apart from so many others. Many molybdenum-based metals suffer from a catastrophic problem called pesting, where they turn into a crumbly powder at high temperatures. But thanks to the clever addition of silicon, this new alloy completely avoids that fate. Instead of crumbling, it remains solid, strong, and ready for action. By carefully balancing just 3 common elements, researchers have created a material that actively fights off the very forces that would normally destroy it. It's a powerful lesson in how small changes in chemistry can lead to giant leaps in performance. You might be wondering, why do we need engines to run hotter anyway? It all comes down to a science principle called efficiency. For machines like jet engines and the gas turbines that generate our electricity, the rule is simple. The hotter you can run them, the more power you get out of every single drop of fuel. This relationship is a fundamental part of how engines work, described by something called the Brayton cycle. A hotter engine burns fuel more completely, and that means less fuel is wasted. This is incredibly important for both our wallets and our planet. Consider this: scientists estimate that for every 100 degrees Celsius increase in an engine's operating temperature, we can reduce its fuel consumption by about 5%. 5% might not sound like a lot, but think about it on a global scale. Imagine thousands of airplanes flying every single day, or massive power plants running all the time. That 5% adds up to millions of tons of saved fuel, and a massive reduction in harmful emissions like carbon dioxide that are released into our atmosphere. Making engines hotter is one of the coolest ways we can make our world cleaner and more sustainable. The best metals we use in our top-of-the-line jet engines today are called nickel-based superalloys. They are incredible feats of engineering, but they have a safety limit of around 1,100 degrees Celsius. If they get any hotter, they start to lose their strength and risk failing. Our new chromium molybdenum alloy can handle temperatures well beyond that limit, while staying strong and protected from rust. This breakthrough means we can finally design and build engines that cross that 1,100-degree barrier, unlocking that next level of efficiency we've been dreaming of for decades. This technology is especially important right now. While we are all excited about new ideas like all-electric airplanes, the reality is that the battery technology needed for long flights just isn't there yet. Batteries are still too heavy and don't store enough energy for a cross-country or an international trip. This new alloy provides a powerful solution we can use in the meantime. It can make our existing engine technology drastically better, helping us save fuel and reduce pollution while other long-term solutions continue to develop. It is a critical bridge to a cleaner energy future. Creating this amazing material in a laboratory is one thing, but getting it ready for a real-world jet engine is a whole new challenge. In the lab, scientists made small samples by melting the elements together in a special furnace, a process called arc melting. Then they used powerful tools like atom probe tomography, which lets them create a three-dimensional map of the atoms to see exactly how the protective layers were forming. These tests proved that the science was solid and that the alloy behaved exactly as they had hoped. It was a huge success for the research team. Now the real work begins. The next step is to figure out how to produce this alloy on a much larger scale. We need to be able to make big, complex shapes like turbine blades, not just small laboratory pucks. Engineers will have to test different manufacturing methods like using metal powders or different heat treatments to see if they can make large parts that have the same incredible properties. They also need to figure out the best ways to join pieces of the alloy together and whether it can be used with special coatings that add even more protection. Before any new material can fly, it must undergo an enormous amount of testing to prove it is safe and reliable. Scientists and engineers will need to see how the alloy holds up over thousands of hours of operation. They will test its resistance to fatigue, which is the weakening of a material from being stressed over and over again. They also need to check how it performs against other things found inside an engine, like water vapor and other byproducts of burning fuel. Every single possibility must be tested to ensure there are no surprises once it's in service. Although there is still a long road ahead, the future for this unbreakable metal is incredibly bright. It represents a monumental step forward in materials science. If the upcoming tests are successful, we could start seeing this alloy used to improve existing engines, making them more efficient right away. Eventually, it could allow for entirely new engine designs that are lighter, more powerful, and cleaner than anything we have today. This is how science works. One discovery in a lab can ripple outward, changing our world for the better and taking us to new heights. The sky is, quite literally, the limit.